So for the atomic radius, it's defined as half the distance between two nuclei of the same type of atom. So that would be, if I'm looking at this diagram right here, it would be as if one of these blue circles was representing one hydrogen atom, and then this other blue circle is representing another hydrogen atom. So it'd be like that. I would recommend copying down this diagram because it's actually a wonderful explanation for the atomic radius. Atomic radius is usually measured in picometers, which are abbreviated as PM. That's essentially 1 times 10 to the negative 12th meters, or in angstroms, which is another unit that measures distance, but it's not one that's used frequently above atomic or macromolecular levels. So we'll use it in this class maybe a little bit around atomic radius, but we won't use it very much otherwise. So for atomic radius trends, before I kind of dive into these different trends, I just want to tell you that whenever we draw arrows of these trends in class, we're always going to draw the arrows in the direction that that trend is increasing. When we're talking about the atomic radius trends, it increases from right to left and then from up to down. And if you take a look at the numbers on here, these are presented in picometers, and you can see exactly what I'm saying. So from right to left, and then from up to down, it's clearly getting larger in those directions. So let's talk about why. So as I go from left to right, I know I'm flipping it a little bit, but I'm going from left to right across the periodic table. I'm adding more and more protons to the nucleus, and I'm adding more and more electrons into the outer energy level. This leads to a greater attractive force between the protons and the electrons. And this attractive force is called the effective nuclear charge, which is helpfully summed up in this figure right here, which might again be one that you want to copy down. I will talk to you more about the effective nuclear charge in just a moment. So since the effective nuclear charge is increasing from left to right across the periodic table, this is actually why when I go from right to left, the atomic radius increases. Okay. And then as I go from up to down on the periodic table, the number of energy levels increases as to something called the shielding effect, which I'll talk a little bit more about later in this video. So this is the main reason why, as I go from up to down, the atomic radius increases. The number of energy levels increases, so the shielding effect increases, and so therefore the atomic radius increases. The reason I put this picture here is because I actually think it's a really helpful analogy for kind of picturing. It's the same sort of like if you had the determination that you were going to carry everything you own in pockets that go on your, and you're going to carry everything around in pockets, eventually you're going to run out of pockets, right? So you'd have to put another piece of clothing on and then put stuff in those pockets. And then you'd put another piece of clothing on and put stuff in those pockets. So it's the same sort of idea as atoms with electrons and energy levels. So it's just a helpful analogy. So I said this earlier, but as I go across a row or a period from left to right, the atomic radius is then decreasing, but that's due to the effective nuclear charge increasing. So let me talk a little bit more about effective nuclear charge. Effective nuclear charge is a little harder to picture. So sometimes it's helpful for people to use an equation to kind of help you figure this out. So if I'm using this equation where F represents the force of attraction between positive and negative charges, then I've got K, which is just a constant. I'm going to ignore it. One of these Q's represents the number of protons. One of these Q's represents the number of valence electrons. And then the R represents the atomic radius. And the thing to know is that if I'm using this and I'm like thinking about how this works in terms of the periodic table, I can kind of sum it up with this. As I increase the amount of charge by getting more protons and more electrons into my atomic system, the force of attraction between those positive and negative charges is going to increase. And since that force of attraction is increasing, that causes the atomic radius to decrease. So it's just another way of kind of picturing effective nuclear charge. Essentially, the idea behind shielding is something we'll explore more in class, but shielding increases as the number of core electrons, and therefore the number of energy levels, increases. For right now, honestly, all I want you to do is copy down this diagram. It's a really helpful diagram for explaining shielding. We will explore shielding more in class. Okay, so your practice question, pretty simple. Using the trends that I've presented in this video, put these in order of increasing, so from low to high atomic radius.